a radical, or more specifically, a square root function example here, we've got the negative square root of x minus 4 plus 2. So I've got the graph already there for you. It's a little bit different than what we were looking at before. A little different than we were looking at before. Now, don't automatically put arrows on the ends right here. Now, yes, there is an arrow here on the right side on the very end, because if we were to zoom out of this graph, we would see that it continues on in that direction. But this point right here doesn't change. That is a starting point right there. We don't go past that. So for our domain, we're looking from left to right. Again, I'm going to keep reminding you of that. So hopefully that's your thought process when you're trying to identify the domain of any function. So if I start over here on the far left of what I can see, I don't have anything. There's no graph until I get to the x value of positive 4. That's where my function starts. So 2 different ways that we can express this. We can say that our x values are greater than or equal to 4, because for any x that's bigger than 4 or equal to 4, we've got a graph. Okay, anywhere from 4 and greater, we've got our graph. Or you also need to be familiar with the interval notation. We put a square parenthesis. Okay, it looks kind of like parenthesis, but we call it a bracket, actually, and that's because it's equal to. So you always do left to right. So the first number on the left was 4. As I go to the right, it never stops. It keeps going until I get to positive infinity. Now, I know it looks really funky because I put a square bracket right here. Infinities always get parentheses. Okay? Infinities always have parentheses because infinity is not technically a number. It's just the idea of the biggest number that we can possibly think of. Well, think up the biggest number you can think of and add 1 to it. You got a bigger number, right? So it never ends. So it always gets parentheses. The bracket is because of the equal to, because we actually equal the 4 is why we put the bracket. We'll look at some situations later where we may not use a bracket there, but for right now, we definitely use a bracket. All right, range, bottom to top. Bottom to top. So if we start at the bottom, I know it doesn't look like we have anything here, but if we zoomed out a little bit, we would see this keeps going down. So we've got our graph down here at the bottom. We go up, we go up, we go up. When we get to this point right here, we don't go beyond that point. So 2 is our highest y value. All of our y values are less than or equal to 2, because 2 is the highest point that we can make, so everything else has to be less than that value. Now, in interval notation, we've got to go bottom to top. So the number on the bottom, we can go down as far as we need to go down. So the number on the bottom is negative infinity. The number for the top is our limit, our highest value that we can reach up there, which is 2. And we do equal to, so we put that bracket there as well. Any clarification needed on the domain and range there? All right, y-intercept. Do we cross the y-axis? No, we have none. That is possible. You don't always have a y-intercept. You don't always have an x-intercept. Now this one does have an x-intercept. It does cross the x-axis at positive 8. And we do want to list that as a point, 8, 0. Okay, increasing to decreasing, we still always look left to right. Okay, we always want to look left to right. So as we move from left to right, our graph is always moving downward. So this one is also decreasing, like our first example was. But it's not decreasing for all real numbers, because we're not defined for all real numbers. We are only defined starting at 4 and going to positive infinity. Notice I use my x values here. Okay, I'm using my x values. Now, it messes with people a little bit. Because decreasing, we're talking about the fact that the y values are decreasing in value. We're going from 2 to 1 to 0 to negative 0.25, etc. Our y values are going down. But we use the x values to describe where that is happening. From 4 to positive infinity, the y values are going down. It's one of those tricky things that's really about the best that I can explain it. Okay? You always use the x values with increase and decrease. All right, extrema, maximums or minimums. We do have a maximum point. We do have a maximum point on this one. We have actually let's call this an absolute maximum, because it is the absolute highest point we will ever achieve, and that's the 0.42. 42 is the absolute maximum. This one does not have a minimum because it continues down for forever. It continues decreasing and never stops there. In behavior here, as x approaches negative infinity, x can't approach negative infinity because this one's not defined over there at negative infinity. So we can't talk about that end. That one does not apply in this situation because we don't go over there. We stop at 4. We can talk about as x approaches positive infinity over here, way over here on the right. Way over here on the right, our y values, they're going down. So when we go down, down is negative infinity.